Before we go into the real details, let's begin by having a look at some of the big themes that underpin everything that we're going to do in this module. What are the big issues that we're really going to be thinking about? The first big issue, the first big idea that we're going to talk about in this module is the idea that glaciers don't stand isolated as things just on their own. They're part of a complex, interconnected global system. For example, this picture you can see atmospheric impacts on the formation of glaciers, interactions between glaciers and the landscapes underneath them, interactions with glaciers in the oceans. Glaciers are a part of the global hydrological cycle. They're part of the global atmosphere, ocean, land surface interaction. There's lots going on at a planetary scale that glaciers and ice sheets are an important part of, and we need to see glaciers in that context. The second big point to begin with is that glaciers come in all sorts of different shapes and sizes. There's even some disagreement amongst glaciologists as to whether we should separate out ice sheets from glaciers and treat them as separate things. For this module, I'm treating ice sheets and glaciers as varieties of the same thing. An ice sheet is just a very big glacier. The reason for that will become apparent in just a second. But glaciers occur at the smallest scale. For example, here we have tiny little niche glaciers perched on the side of a mountain. Here we have an ice field which is draped across the topography. Still, the topography is clear underneath the ice, but the ice is covering a large part of that landscape in that ice field. Here we have an ice cap which is covering a larger part of a landmass, and here Vatnajökull in Iceland is a good example of an ice cap, is completely obscuring the topography underneath it. At a bigger scale, ice sheets do the same thing. The main difference between an ice, well, the difference in definition between an ice cap and an ice sheet is simply one of scale. Check up these definitions in your reading when you follow up this session. And then here we have the typical, if you like, fairy tale storybook version of a glacier. This is an alpine valley glacier, which is what most people probably think of when they first imagine a glacier, but that's only one of many different types of glacier that we'll be looking at. And they occur all over the world, on the equator, at high latitudes, up mountains. We'll be looking at examples of glaciers from all over the place. The third big point I want to make, and this really underpins a lot of what we're talking about and goes back to that issue I raised about whether we should treat ice sheets and glaciers as separate things, is that even though there are lots of different types of glacier, they all follow the same basic rules. So in these images, for example, here's a little bit of the edge of the Greenland ice sheet. Here on the right hand side is a little mountain glacier from Ecuador, Chimborazo in Ecuador. This crevasse in the middle is actually part of it's from this area of the Greenland ice sheet, but that feature could occur on a big ice sheet, it could occur on a small mountain glacier. The way the ice moves, the crystal structure within the ice, it's similar, it's connected, it's related. They follow the same basic rules whether they're little mountain glaciers or big ice sheets. We wouldn't need to have a whole separate module about niche glaciers, or a whole separate module about valley glaciers, or a whole separate module about ice sheets in order to get to grips with the basic rules that determine how glaciers work and how glaciers and ice sheets affect the landscape. And so that's what this module is going to be focusing on, is those shared basic underpinning rules about how glaciers work and how they affect landscapes. Now, there are two particular examples of rules that apply to all sorts of glaciers that we're going to come back to over and over again throughout this module. This isn't a mathematically based module. There isn't it isn't a numerical module. There aren't lots of equations, but there are two relationships or two equations that we will revisit during the module. I often joke you should get these two tattooed about your person, tattooed one on the inside of each eyelid. Glen's flow law, which talks about the relationship between how hard you push something and how far it moves, or how far you squeeze something and how much it deforms. That's what Glen's flow law is about. And the driving force behind movement is stress, particularly shear stress in glaciers. And so our second rule that we need to be aware of is the rule about the factors that control this driving force, this shear stress. And I'll talk about those separately later on, but for now just be aware of those two labels. The shear stress equation and Glen's flow law are two relationships that we will need to understand. But they're nice examples of rules that apply to all different sorts of glacier, whether you're talking about small ones, big ones, recent ones, ancient ones. These rules apply to all of them. The next big point or big theme that we'll be relating to in the module is that glaciers, again, they don't just sit in a local context, they don't just sit in a global context, they do both. They're part of the global environmental system. They also affect and are affected by their local environments. So in this example, for example, an outlet glacier in West Greenland coming off the Greenland ice sheet, the river that's coming off that and flowing through the valley in the front, the fluvial geomorphology, the sedimentology, the seasonal variability in the flow regime in this river, all of those are controlled by glaciological factors. It's the characteristics of this glacier and the way that the glacier responds to its climatic and regional environment. That's what's controlling the small-scale processes going on within the river system, within the sediment system, within the proglacial system going all the way down towards the ocean. So glaciers aren't just big global things, they are also important local things in the areas where they exist. Number 5, glaciers, as well as being local, they are global. They have long distance impacts, and there are some examples of that here. In the main photo here from Baffin Island, you can see this glacier is pouring sediment out into the ocean, and that is affecting the global oceanic system. These sediments will be deposited in the ocean basins. Water from the glacier is going to be affecting the ocean system. You can see hidden behind me here a diagram which I'm sure is familiar to you of the global oceanic thermohaline circulation. That's controlled in part by meltwater from glaciers, leading to the sinking of cold water in certain areas of the planet, for example off southeast Greenland. Another example here in the top left, these are raised beaches on the west coast of Scotland, just to remind us of the impact of glaciers on global sea level change. As glaciers come and go, sea level rises and falls. Those sea level rises and falls have an impact on the geomorphology of landscapes far away from where the glaciers are actually existing. So glaciers have long distance impacts. They also have long time duration impacts, long-lasting effects. I mentioned earlier that the systems that they're part of are both historical temporal systems as well as global spatial systems. And here's a picture of the Langdale Valley in the Lake District in northern England. And this landscape, very much glacial in nature, has been sat like that, changing slightly but retaining its glacial characteristics for 10-20,000 years since the last glaciers were there. Once glaciers go, the landscapes that they leave behind can persist for a very long period, which is an interesting thing to explore in the context of long-term landscape change. How long will a glacial landscape survive in an environment once the glaciers have gone? Even around Kiel, for example, where most of you doing this course are based at the moment, our landscape is very much a glacial landscape, a glaciated landscape, and you can find evidence around here of glaciers that left about 20,000 years ago, but their impacts are still visible in the landscape. So drawing on those big themes that the module is going to be focusing on, these are the topics that we're going to talk about. We're going to look at how glaciers work. By the end of the module, you'll be able to explain how glaciers are formed, how they move, how they impact landscape, and so on. So how do glaciers actually work? What's the mechanics of that? How do glaciers fit into their local landscape, but also how do they connect to their global landscapes? How do they fit locally and globally? And finally, how do they create specific landforms and regional landscapes, assemblages of landforms that survive after the glaciers are gone? So we're looking at the glaciers, we're looking at their connection to the global and local system, and we're looking at the ways in which glaciers create landforms and landscapes. Now, a central idea in this course is that the global environmental system controls the characteristics of glaciers. So you can see I've labeled this control down the left-hand side here. The global environmental system is controlling the way that glaciers work and the characteristics of glaciers and glacial processes. Those characteristics of glaciers and glacial processes are then controlling, or they're having impacts on landforms, hydrology, sea level, the nuts and bolts, the details, if you like, of the physical geography. So we can draw a control arrow, sorry it's hidden behind me on the screen here, but we can draw a control arrow all the way down the left-hand side here. The environment, the global system, controls the glaciers and the glacial processes impact and control landforms, hydrology, sea level, etc. We can also, however, draw these arrows back up the right-hand side of the diagram, where looking at the evidence left behind, we can infer things about the controls on those characteristics. So, for example, by looking at landforms, which is something we're going to be doing in this module, we can work out from the characteristics of the landforms some of the characteristics of the glaciers that created those landforms. It's like detective work. You look at the geomorphology and you work out the glaciology of the glaciers that have long disappeared. If you can work out something about the characteristics of the glaciers that have long disappeared, then you can also, working up the diagram, you can also work out something about the nature of the environment and the global system at the times that those glaciers existed. So we're doing two things. We're working out how these things control each other to give us the landforms and landscapes that we're seeing around us now. And we're also seeing how scientists can work backwards from the evidence embedded within or embodied within the landforms, work backwards to see the characteristics, figure out the characteristics of ancient glaciers and the ancient glacial system. Now, in doing that, as you'll be beginning to realize already from all the different things I've briefly mentioned in this section, there are lots of different things we're going to be looking at. We're going to be talking about glaciers, glacial processes, examples of specific glaciers, specific processes, specific glacial landforms and the landscapes, aspects of the environment that they're created within. At this stage, you should begin, and at this stage it can just be a blank piece of paper more or less, but I want you to begin drawing your own conceptual map of all of the components of this course. And gradually, as the course proceeds, you'll develop this map, and at the end of the module, you'll have all the different things that we've talked about set out in context relative to one another so that you can see the connections and the interactions between all these different individual things that we're looking at. So for now, just set aside a file on your computer or a piece of paper or a section of your bedroom wall that you've whitewashed, however you want to do it. But just set aside a space now for drawing a map that ties together all the different topics that we're going to talk about. And we'll come back and we'll revisit that at various from time to time throughout the module. So where does that leave us right now? So from this section, you should know roughly what the module is all about. You should understand that there are lots of different types of glacier, but they all share common characteristics that we can look at during the module. Glaciers are interconnected with a global system that partly controls their character, but also in some ways is controlled by their behavior. And so at this point, you should now be ready to move forward and look at some of the more detailed information about glaciers that we're going to get onto now as we move forward into the module. So what next? Well, you're embarked now on the 12-step program, so you're into the module. We haven't got into real detail yet, but we've got a general idea of what's going on. So at this stage, just carry on working through the resources in this first step of the program, and we're going to look in more detail now at a couple of the items that we've raised in this section. So just keep working your way through the program. If you have any questions, just get in touch. Thanks very much.